everyone. Welcome back. Today we're going to talk about algebraic reasoning, graphing, and connections with geometry. So first off, we're going to start out with corresponding scenarios. Our first question, we're going to identify a graph that represents the amount of gas in a tank when a driver refills the tank. Now when we think about somebody that is driving, the more you drive, the more gas you lose. Well, when you stop to fill up your tank, you're going to have a sudden increase in how much gas you have. So we're going to draw a little graph here to kind of get an idea. Let's say we have a full tank right here, full. And we drive and drive until we get low. Well, then we want to fill up with gas. So this line going straight up is going to represent our fill up. Well, once we start driving again, we're slowly going to lose gas again. And when we look at the graph that we've created, we'll notice that this one right here, the third one, is going to be the most similar to that scenario. Again, for our next question, we are going to identify a graph that represents the height of an elevator stopping at each floor on the way up. When we think about an elevator, on your way up, you stop at each floor. We'll draw our mini graph down here. So we're going up a floor, and then we stop. And we go up a floor and stop. And it just keeps going up, kind of like steps, until we eventually get a graph that's similar to the fourth one right here. Which means that the graph that's going to represent this scenario the best is going to be our fourth graph. For our next question, we're going to identify a graph that represents the height of a bouncing ball. Now, we've all had a bouncy ball at some point growing up. If you'll notice, when you go to bounce it, it slowly just keeps losing its bounce until at some point it stops. Which kind of gives us this springy little motion right here, where it eventually just stops bouncing. And if you'll notice, our first graph right here is the best representation of what we just drew. Again, for our next problem, we're going to identify a graph that represents the length of a flagpole shadow throughout the day. Well, throughout the day, our shadows will go from teeny tiny like that, and we'll draw a tree. Well, no, we'll draw our flagpole. Let's see. So we have our flagpole right here. We'll have a little flag waving on the top. Throughout the day, our flagpole goes from a teeny tiny shadow, and it slowly just grows as the sun comes up. Well, once the sun starts to set, our flagpole shadow is going to go down and down until it is no longer there. So the best representation that we can have of, or the best kind of graph that we have here that's going to represent that shadow is going to be our second one. Because it starts out at nothing, grows throughout the day, and then shrinks. Let me get the screen off. So next up, we're going to talk about graphing and functions. This is going to be for question number 2. We want to solve and graph for f of x if f times g, or when we have f of g of x, when f is 3x and g is x plus 8. I already went ahead and I created our equation, which we'll kind of write it out up top so you have an idea of how you set it up. We have f of x, which is equivalent to f of g of x. Well, we know that our f of x is going to be 3x, and then we want to plug in our g of x, where our g of x is in our equation, which is going to be x plus 8. So our problem should be 3x times x plus 8, which we have right here. So all we're going to do we're going to find random points. We're going to start out with 0, 1, 2, and 3, and we're just going to kind of graph them on our graph. So first we have 3 times 0 plus 8, which, just following the rules of PEMDAS, we start out with our parentheses. So 0 plus 8 is 8. 8 times 3 is going to be 24. Or not, yep, 24. Next we have 1. So 3 times 1 plus 8. Well, 1 plus 8 is 9. 9 times 3 is going to be 27. Next we have 2. So 3 times 2 plus 8. 8 plus 2 is 10. 10 times 3 is going to be 30. And then we have 3 times 3 plus 8. 11 times 3 is going to be 33. And now we have our points. So we have 0 for our x-axis, 24 for our y. We're going to go ahead and graph that. 0, and forgive me, my points are a little off. It's going to be 10, 20, 30, 40, 50. And we'll get a different color so we can kind of follow along. We have 0 over 0, which is right here, up 24. So that'll be our first point. We have 1. We'll treat this like this because my points are slightly off. For 1, we're going to go over 1, up 27, so over and up. Next we have 2, 30, so we're going to go over 2, up 30. And then we have 3 for our x and 33 for our y. So we're going to go over 3, up 33 for our y. And eventually we'll kind of develop this line right here that's going to represent our equation. So for our next section of this lesson, we're going to discuss slopes and line segments. So for this question, we're given 2 points on a graph. We have P, which is going to be 3 on the x-axis, y on the 1, or 1 on the y. And then we're going to have Q, which is 5 on the x and 5 on the y. Now, first of all, we want to find our slope for these points. And notice how we already have a formula down. It's y2 minus y1 divided by x2 minus x1. We're going to go ahead and label our points so that we know what's what. For our first point, P, we're going to put x1, y1, since that's our first set of points. And for our Q, we're going to put x2, y2 for our points. So now we can just simply plug these in our formula. Our y2 is 5 minus y1, which is 1, over x2, which is 5, minus x1, which is 3. So 5 minus 1 is 4. 5 minus 3 is 2, which means if we were to simplify this, our solution would be 2. So our slope is going to be 2. Well, now we want to graph these points. So if we look at our P, we have 3, 1. We're going to go over 3, up 1, and that'll be our point right there. For Q, we're going to go over 5, up 5. That'll be our point right there. And we will get a line similar to this one. Not quite as messy, but similar. And if you'll notice, our line intersects at this point right here. And this is where our slope kind of comes in, because we have a slope of 2, or 2 over 1. So we can go up 2 over 1, and there's our point. Again, we can go up 2 over 1. Well, there's our next point. Now for our next example, or next problem, we're going to look at these 2 points right here, and we're going to go ahead and find our slope again. And I'll go ahead and switch out my colors just to switch things up a little bit. We have our x1 and our y1, and then we have our x2 and our y2. We're going to do y2, which is 4, minus y1, which is 1, over x2, which is 3, and x1, which is 1. So 4 minus 1 is 3, 3 minus 1 is 2, so our slope is going to be 3 over 2. Well, now we want to go ahead and graph these points. We have our first point R. We're going to go over 1 and up 1. For our point S, we're going to go over 3, up 4, and we'll develop a line like this. And if you'll notice, if we go up 3 over 2, well, there's our slope right there, and it meets up with our next point on our line. Next, we're going to discuss graphing and relationships. So we're going to go ahead and graph the following. Notice how in our table we're given an equation, y equals x squared. We can go ahead and plug in some random points. I went ahead and did 0, 1, 2, and 3. We can do 0 squared, which is going to be 0. 1 squared, which will be 1, which is 1 times 1. 2 squared, which will be 4, because 2 times 2 is 4, and then 3 squared, which will be 9. So now that we've kind of gotten all of those numbers down, we can go ahead and determine what our points are. We have 0, 0, we have 1, 1, 2, 4, and 3, 9. So we're going to go ahead and graph those, and we're going to pretend like this point right here is our 0 on our x-axis, and then we'll have our -1, -2, 1, and 2. So for our first point, we're at 0, 0, which is easy. We'll mark it right there. Our next point, we have 1, 1. Our next point, we have 2, 4. And if you'll do the same equation with -1, -2, -3, you'll notice that you'll have a point right here, you'll have one right here, and your line is going to make this weird U shape, which is a parabola. It goes like that, just because we squared our x. So next up, we're going to talk about perpendicular lines. So what we're going to do, we're given an equation right here. Y equals -3/4 x plus 5. We want to find the reciprocal of this, but we want that reciprocal to go through the point 6, -1. So what we're going to do, we are going to pretend like our 5 isn't there. We're just going to flip our -3/4, and we're going to change the sign from negative to positive, since it's going to be the complete opposite. So we're going to start out, we have our y equals 4/3 x plus, and we're just going to put a b instead of 5 just to fill in that space. So next, what we're going to do is we're going to plug in our points for x and y, so that we can find our new b, our new spot, or number for our 5 spot. So we're going to put in -1 for y equals 4/3 times 6 plus b. And you're welcome to do some mental math to solve for this. I'm actually going to pull out my calculator real quick. And we're just going to go ahead and do 4/3 times 6, which is going to give us the solution 8. So -1 equals 8 plus b. Well, now what we want to do, we're going to subtract our 8 from both sides because we want to isolate our b. And we will be left with -9 equals b. So now when we solve our equation, it's going to be perpendicular to our original equation. It also goes through that point. We're just going to plug in -9 for our 5. And we're going to keep our 4/3 that we'd started out with. So our equation will be y equals 4/3 x minus 9. And that'll be our solution. Next, we're going to talk about tangents on a circle. And if we'll notice the question, it says show the equation of the line that is the tangent to the circle of radius 9 at 0, 9. Let me get my screen right up. Well, when we look at our circle, the center is going to be 0, 0. And when we're looking at a graph, if our circle's radius is 9 and our tangent is at 0, 9, we can automatically assume that this point right here at the edge of our circle will be 0, 9. Well, this is the point we want. We want to find our tangent, which is going to hit only one point of the circle, which means that we will have a line crossing the circle right at the edge, right here. It is perpendicular to our y-axis. Excuse me. And when we go to look for our solution, if we'll notice what point our y is at, it's actually at 9 all the way across. It doesn't go any higher, it doesn't go any lower, so our solution would simply be y equals 9. So that is it for today, guys. I hope y'all have a great day. I hope you learned something, and I'll see you next time.